In this video, we're talking about how to use substitution to solve a system of linear equations. And remember that there are three different ways that we can solve a system of linear equations: substitution, elimination, and graphing. And of course, in this video, we're going to be talking about the first one, substitution. So the system of linear equations that we've been given is 2x minus y equals 10, and our second equation here, 4x minus 3y equals 16. So we need to use substitution, and when we use substitution, what we're going to do is take one of our equations, solve that equation for one of the variables, it doesn't matter which one, and then take the value we find for that variable and plug it into the second equation. So again, we can start with either equation, we can solve either equation for either variable. So we're really looking for the easiest variable to solve for, and in this system of linear equations, it's probably going to be this variable here for y, because this variable for y has a coefficient of -1 instead of 2, 3, or 4 here. So let's try to solve this first equation for y. The way that we're going to do that is by subtracting 2x from both sides. When we subtract 2x from both sides, we'll get -y is equal to 10 minus 2x. Now we want to multiply both sides of the equation by -1, because -1 times -y will give us positive y, and we're trying to solve for y. So we get y is equal to -10 plus 2x, because the -1 changes the sign on every term in this equation. So positive 10 becomes -10, and -2x becomes positive 2x. Now that we have y isolated by itself, we have this value for y. What we can do is take this value for y and plug it into this second equation here for y, and then we'll have an equation in terms of x only. So we'll get 4x, and that's where the substitution comes in, right? We're substituting this value for y into the second equation. That's why we call it substitution. So we're going to get 4x minus 3y, but instead of y, we're going to put in -10 plus 2x, and that's going to be equal to 16. Now we just need to simplify this equation and solve it for x. So we'll get 4x, -3 times a -10 is a positive 30. -3 times 2x is a -6x, equal to 16. We'll collect like terms and say 4x minus 6x is a -2x, so -2x plus 30 equals 16. Subtracting 30 from both sides, we're going to end up with 2x equals -14, and then dividing both sides by -2, we'll just be left with x is equal to -14 over -2, which is positive 7. So now we have this value of x equals 7, and we need to find the associated value of y. Conveniently, of course, we already solved for y, right? We found this equation for y in terms of x, so we can plug x equals 7 into that equation to easily find a value for y. So when we do that, we're going to get y is equal to -10 plus 2x, or -10 plus 2 times 7, because we said x was equal to 7. So now we get y equals -10 plus 2 times 7 is 14. Y is equal to positive 4. Now we have a value for x and y. Remember that we plugged x into this equation here to find a value for y. Well, this equation here is just a rearrangement of our first equation in the given system. So really, we use this first equation here to find the associated value of y. So we know that the set x equals 7, y equals 4 satisfies this first equation. But remember, we're dealing with a system here. We have to double check to make sure that it also satisfies this second equation. So we want to go ahead and plug x equals 7 and y equals 4 into our second equation to make sure that that equation is still true. So we got 4x, but we know that x is 7, so we have 4 times 7, minus 3 times y, we know y is 4, so minus 3 times 4 is equal to 16. When we simplify here, 4 times 7 is 28, 3 times 4 is 12, so 28 minus 12 equals 16. 28 minus 12 is 16, so we get 16 equals 16, and that checks out. So we know that x equals 7, y equals 4, that 0.74 also satisfies our second equation. And remember, even though we started with this first equation and we solved it for y and then made our substitution, we could have solved our first equation for x and then made the substitution into the second equation here for x, or we could have solved the second equation for either x or y and then made a substitution into the first equation for x or y. So there's 4 different ways you can do this just with substitution alone, and then of course to solve a system of linear equations you can also use elimination or graphing, but that's how you use substitution to solve a system like this one.